Okay, well, it's Friday, and so that means our first week, we are wrapping up our first week of school. I guess that means we're 10%, well, after today, we'll be 10% of the way through the quarter. And yeah, the time just will keep ticking on. Okay. I've seen a lot of good discussion on Campus Wire, so I'm thankful for that. I hope by now all of you have at least started the homework assignment and have at least taken a look and things like that. Please do try to, I would say, make sure while you're working on it, try knitting it to a PDF file. Trying to figure out how to knit your PDF file and all of this stuff. Like right before the due date is not the good time. So do it well in advance. You might, if you don't already have some kind of LaTeX installation, you might have to install that. There's been some questions about that on Campus Wire, and I think some good discussion at least as far as tips go for getting that going. Someone asked if I'm going to upload this to the to CCLE. Yes, I have uploaded the presentation slides on CCLE, so they are up there. And let me also turn on, let me just make the Friday viewing quiz visible as well. Okay, yeah, and this is technically just the student asking if I'm going to upload the PowerPoint. It's not a PowerPoint. This is a Beamer presentation created with LaTeX and R Markdown. So I mean, I love PowerPoint, but I do want to be clear that this is not a PowerPoint thing. Well, why don't I go ahead and give you your first view quiz answer for today. The very first view quiz answer for week 1 Friday is B as in bear. B as in bear is your first view quiz answer. That's what we have for week 1 Friday, first view quiz answer. All right, okay, we'll go ahead and get started. Today's lecture is on subsetting. Subsetting is all about taking a big thing and just pulling out the pieces that you need. And so I think I saw on Campus Wire someone asking, like, how do we filter out certain elements in a vector and things like that? That's going to be one of the things we talk about today. We'll talk about all sorts of other stuff, you know, subsetting data frames. And a lot of times we think of subsetting as taking a big thing and shrinking it down, but we're not limited to that. The various functions that power the subsetting can be used for all sorts of other stuff. So we'll take a look at all of that. Yes, B is the answer for the first view quiz answer, just to answer the question in the chat. I hear a lot of, sorry for the noise in the background here. All right, okay, so just for simplicity, the very first example that we'll do for subsetting is going to just be subsetting this atomic vector x, okay? And I've got the numbers 2.1, 4.2, 3.3, and 5.4. These are intentionally not in order from least to greatest, but just so you can see where it is, I've got a 0.1, a 0.2, 0.3, and 0.4 to kind of indicate the position that the element is in the original vector, okay? So like 4.2 is in the second position, the 0.3 means it's in the third position, just so you can kind of follow along. And so I think you're familiar already with a lot of these things, but I'll point these out and we'll go, okay? So you use single square brackets to subset, okay? And you can subset using the position. So you can say, I want to subset X, I want the element in the third position and the first position, and it pulls out 3.3 and 2.1, okay? 3.3 and 2.1 for the third and first elements, okay? There are functions that will return the index that you need to use in order to put something in order, okay? So order, you have sort. Sort will take vector X and sort it from least to greatest, or whatever you need. And here order will give you the index, kind of will tell you if you want to put X in order, first take the first element, then the third element, then the second element, and then the fourth element. and that will put it in order from least to greatest. And you can see that if we do that, indeed, it will go from least to greatest for the order vector there. Okay, so X subset on order of X is the same thing as sort, but sometimes you just you need to know the position and things of what it goes. Okay, this is different from rank. Okay, it's a little different. Okay, all right, so subsetting, okay, oh yeah, we're continuing to do that. If you put the same index in there twice, R will subset and give you the first element twice here. So if I say subset X with a 1 and a 1, it gives me the first element 2.1 twice, okay? If you give it something like, so it's expecting integers, positive integers here. And if you give it something that's not an integer.
Sorry, what device?
I don't know, Alexa thinks I'm talking to her.
Sorry, I didn't find a device named on.
All right, that's fine. Okay. If you give it something that's not an integer, like 2.1 and 2.9, R just kind of truncates it, okay? It doesn't round, it just truncates to a 2, and it gives us the second element there, okay? If you give it negative integers, right? If you give it a negative number, it's going to throw those numbers out, right? So if I say negative 3 and 1, it'll give me everything but the third and first elements, okay? And it'll give it just kind of in the order that it appears. So it's going to give me the second and fourth elements here. You're not allowed to mix negative and positive integers because that's just ambiguous and confusing, right? So you're basically saying, I don't want the first element, I do want the second element. And then R is kind of wondering, like, do you want the third or the fourth, or you don't want those? I don't know what you're saying, right? So you can't mix negative and positive numbers here. Probably one of the most useful things is subsetting with a logical vector, okay? So if you have a logical vector, so here I've just kind of manually typed out true, true, false, false, and things like that. And it's going to give you back the elements that correspond with trues, and it will not return the values that correspond with false, okay? So here, trues in the first and second position, so it will give me back the first and second values in X, okay? And it doesn't give me the third and fourth. Here, X greater than 3, this is a logical expression. It's going to ask which values of X are greater than 3. And so if we were to evaluate X greater than 3, that would be false, true, true, true. And so it's going to give us the elements that correspond to true, and thus it's going to give us the elements of X that are greater than 3. Okay, and I think you guys are familiar with this, yes? Yeah, okay, so you'll just kind of do logical subsetting here. All right, if the rules of recycling apply as well, okay? And so, so here, X is a vector of length 4. And if I recycle, say the vector, if I subset based on true and false, this is equivalent to recycling it to true, false, true, false. Okay, and then that will return basically the first and third elements here. So if you give it a vector that's shorter than the original, it will recycle it. Okay, and so recycling meaning it's going to kind of repeat these over and over, and there you go. Okay. If you give it, say, a vector like this, true, true, NA, and false, giving a missing value in the index will always kind of return a missing value here. Okay. So it's going to give us the first and the second element. It's going to give us a NA corresponding to the NA, and then false, which would have corresponded to the kind of the fourth value here, goes there. If you do something like true comma NA, it would recycle that, and it would become true NA, all right? And then so you get 2.1, an NA for the 4.2, the 3.3 gets pulled out, and then an NA for the 5.4, right? So you can do this, and it would kind of do that. All right, a couple special cases. When you subset with nothing, it returns the original vector, all right? So, you know, generally you wouldn't do something like this, okay? But for matrices, if you want everything in, say, row 1, you can leave nothing for the column, and you'll just indicate, you know, I want x1 comma to say I want row 1, and then comma space comma nothing, and it will give you everything, all of the columns pretty much, okay? If you put 0 inside here, okay, it will give you a 0 length vector, right? So x is a type double or type numeric. And so here, if you give it 0, it's going to give you a 0 length vector of that type, data type. So here we get a numeric 0, okay? Generally, you don't do this on purpose, but if you kind of need to generate some empty test cases just to kind of see like what would happen if I feed in a 0 length vector, like is that going to break my program? Because sometimes that happens. Sometimes that happens. You'll get, you can try it out. All right, so that's subsetting with kind of integers, positive and negative integers. We can also subset with character vectors, right? So in R, you can take a atomic vector and provide names, okay? So if I take the vector x, I can give it names, right? And there's a few ways I could have done this. I could have said names of x, set that equal to letters 1 through 4, or something like that. But here I'm going to create a new vector y. Y is going to be the values in x, but we're going to give it the names A, B, C, D, okay? Are you guys familiar with the built-in vectors letters, lowercase, and the built-in vectors capital letters? This is just a very quick way to kind of, like if you need to name things A through Z, just kind of, these are already kind of just preset. You can just say letters and you get lowercase, and if you do letters, you get caps A through Z. It's very, very handy. Okay, so anyway, we're gonna just give it A, B, C, D, all right? And so here, if I subset Y and I say I want D, C, and A, all right, then it'll give us the ones that correspond to D, C, and A. I don't think that's a surprise. Kind of like the integer indices, you can repeat them. So you can say subset Y with A, and you're going to get 2.1, the one corresponding to 2.1 multiple times, okay? Whenever you subset, okay, it expects the name to be spelled exactly, okay? So here, if I create a vector Z and the names are A, B, C, and D, E, F, and I say, hey, I want something A and I want something D, it's not going to find a match, okay? And so anytime you kind of give it, I say, you know, subset based on this character or something, and it doesn't find it, it's going to return an NA. It's going to say that doesn't exist in Z. So you're going to get something like this. So one useful application is to apply to kind of create a lookup table, okay? So here I have a vector x, and perhaps this is like a vector of genders, okay? And we've got M, F, and U, and F, and M, and things like that. And perhaps we want to, instead of just using these letters, we want to switch them to, say, male and female, or missing, or, you know, something along those lines, okay? And so what you can do is notice how I'm going to apply the subset. I'm taking lookup. Lookup only has 3 elements in it. It's got the what kind of vector is lookup? Lookup is a character vector. It's a character vector where the elements are male, female, and missing, or NA, and it has the names M, F, and U, okay? So this is a character vector and of a length 3, but notice I'm quote unquote subsetting the labeled vector with the kind of the labels here in X. And so now it's going to return, basically it has, because we can kind of provide the same index multiple times, it's going to provide kind of the full names, or the, you know, the full lengthier versions here, and we got male, female, NA, female, female, male, male, and things like that, okay? And if we want to get rid of the names up here, we can do that. We can just take the function unname, and then we get the results here, okay? You can probably do something similar to this for like your months renaming thing in your first homework, okay? I mean, you don't have to take this approach, but I think this is a simple approach. You just kind of apply this to the levels vector. Levels is a character vector, and you apply something like this to that. Okay. Is that all right? This lookup table business? Okay, so that's atomic vectors, and now we can take a look at subsetting lists. All right. So subsetting a list is similar to subsetting an atomic vector, except with lists, there's sometimes you need to be able to distinguish between the list element and the contents of the list element. Okay. So when you use a single square bracket with a list, it will always return a list, okay? The thing that it will return is a list, right? Just like if you subset a character vector, it's gonna always return, you know, basically a character vector. And so if you take a list and you subset a list, it's gonna return a list that has kind of been subset. If you need to extract the contents of a list, then you use the double square bracket, okay? Or if you've got names, you can use the dollar sign, all right? And so that will pull out the elements or the components of the list. So the subsetting operators, the double square bracket and the dollar sign are similar to the single square bracket, except it can only return a single object, as it allows you to pull the pieces out of the list, okay? The dollar sign is basically a shorthand for the double square bracket, but it's used for a named list, okay? And a good analogy is that if you think of a list as a train, okay? So think of a sequence of cars, okay, and a train, then the double square bracket 5 is taking the contents of train car number 5, okay? It's the object inside train car number 5, whereas the single square bracket 4:6 will be the actual train cars, train car 4, train car 5, and train car 6, okay? So so if you think of a list as a train, then single square bracket will return the trains, the train itself. Double square bracket will return what's inside the train car. Okay, so here is just kind of an example. I've got A is a list of length 2, okay? I've got X is 1 through 4. This is kind of the first train car is named X, and inside of that train car is 1, 2, 3, 4. The second train car is named Y, and inside of that is 9, 8, 7, 6. If you do a double square bracket 1, that will pull out the contents of the first train car, the content of the elements inside the contents of the first list element, and that will give us an integer vector, 1, 2, 3, 4. If I do a double square bracket Y, it will give us the elements or the contents of the list named Y, and that will give us 9, 8, 7, 6. Okay, you can give a single square bracket with a vector of multiple items, okay? And so this is basically asking, give me back a list of elements Y, X, and X, okay? And so this is going to return basically a train of basically car X, Y, car X, and a duplicate of car X, all right? That's what we have here. But if you try to do something like this, right? I've got a double square bracket, and I'm giving it a vector YX, this doesn't work, okay? Because, and the reason why is that the double square bracket can only return one thing, okay? So it can't return the contents of Y and the contents of X, because you know what, these two things might not be compatible. Here they're both integer things, so we think like, oh, we could just kind of combine them together. But this could be a function, right? The contents of a list element could be a function or a data frame or something. And you want to just be able to combine an integer vector with, say, a data frame in a simple way, okay? So this is a side note, okay? This is technically not an illegal operation. You could do this. This is going to invoke something called recursive subsetting. And so this operation, double square bracket y, x. So you don't have to learn this, okay? But I'm just throwing this as a, like, it could actually work. But this would be the equivalent of doing double square bracket y and then double square bracket x, okay? And what this means would be, look at basically list A, give me the contents of list element y. And within that, if y itself is a list, give me the contents of element x. So here I've created a list, okay? A list with x and y itself is a list with elements x and z, okay? And so you can see the contents of this in that I've got initially I've got a list of 2 at the top level, x and y, and within y, so it's like I've got a train of 2 cars. And it's like a little bit of like an inception train. Inside train car Y, I have another train with X and Y and X and Z inside. Okay, so it's like I've got a small train inside the train. Okay, and in that case, this could work, right? And there's actually a lot of like nested lists inside of lists that, like, if you look at, say, the results of an LM operation. Have you guys already used LM in your 101A class, right? And then you're starting to look at that. And so if you look at the contents of the model output of LM, it's a big list, and it's like lists of lists and stuff like that. And sometimes you need a way to reference those things, and you can do that like this. So you can say, inside Y, I want to look at X, and that's going to be this character vector A. You can also, that's what this instruction with the combine is the equivalent of this. I think this is more unambiguous, and this would be my preferred method for referencing elements. I would actually probably use $y, $x to reference the same thing, but this is allowed as well. Okay, but that's a side note. All right, so here I'm creating a list D. Okay, D is a list of length 3. Okay, and the elements in D are A, B, and C. A is a numeric vector 1, 2, 3. B is a logical vector true, true, false, and C is a character vector A. Okay, let's see. So far, every example has a name. Is that good habits for easy finding? Okay, yeah. So yes, you are correct. All of the examples I've done so far have names, but I will do some examples without names. Naming elements in your list are good if the elements in your list have semantic meanings or significance that can be named. Sometimes you just have a list of things that shouldn't be named, and in that case, maybe not. But you know, if it makes sense to give things names, then give it names, and if it doesn't, if it's better to treat them as unnamed things, then don't. The answer is always it depends, I guess. Okay, so here D is a list of length 3. You can use a single square bracket. Again, when you do a single square bracket, the object that gets returned is always a list type. Okay, and we can tell it's a list type because it says $A here. And if I ask type of on D single square bracket 1, it says this is list type. Whereas if I do the double square bracket, it returns the contents of the first element. Okay, and that will tell us, oh yeah, that's a numeric or type double vector here. Okay, and so this is important. The distinction between single square brackets and double square brackets, I cannot emphasize enough, or I don't know, maybe I am emphasizing it enough here. And sometimes your programs fail to work because you're using a single square bracket when you should be using a double, or vice versa, and things like that. Okay, so here's an example of a list where it's a list of length 3. but I have not given it names, okay? And so here we've got a list of 3, and I've got an integer vector, a character vector, and another integer vector, okay? And so these things don't have names, right? So I can't reference the first things using using names like I did. Well, actually, I didn't use them over here. I didn't even use the names. But they don't have names, but you can still kind of use it, right? And so here I've got list 1 single square bracket 1. Okay, it's going to return. This is a list, the kind of the first train car or the first list element, and we can tell it's a list because it does double square bracket 1 to kind of indicate this is a list. And then the contents of double square bracket 1 is a vector, new integer vector here. Okay, whereas here if I do L1 double square bracket 1, that gives us back the integer vector here. Okay, so so what happened here? Okay, so if I do single square bracket 1, single square bracket 2, I get back null. Okay, so if you think about this, right? What is this? This is a list. It's a list of length 1. Okay, L1 single square bracket 1 is a list of length 1. And so here I'm asking, okay, give me the second element of this list of length 1, right? It's kind of just like saying, all right, here we've got L1, which is kind of a train of 3 cars. L1 single square bracket 1 is the first train car. And then I'm saying, okay, give me the second element of this. Okay, well, there's no second train. So we get back a list containing null. Okay. All right, over here though, L1 double square bracket 1, that refers to this. This is the contents of the first list element, okay, the contents of that first train car. And then we're saying, okay, give me the second element in here. This is an integer vector of length 8, and we can say, give me back the second element. And so this is going to give me back number 2. Is that all right? The distinction between this thing and this thing, okay? Because probably somewhere along the way when you're working with the lists and you're writing code and stuff like this, and you say, you know, subset list 1 to, you know, position I and position J and things like that, I imagine somewhere along the way you'll run into an error like this, okay? And it's going to be because you've mixed up the single and double square bracket, okay? Here, this is recursive subsetting, okay? And this would be equivalent to doing this, double square bracket 1 and double square bracket 2. You can do double square bracket on a regular old atomic vector. It's possible, you can do that. And it would give you back the second element. So this would be equivalent to that. All right, so here we've got a list inside a list, okay, a train inside a train. All right, so here I've got L2 is a list, okay, of 3 elements, all right? And the first element is list 1, L1. And then I've got some vector 10, 20, 30, and some vector D, E, F, G, H, I, something like that. Okay, so here I've got a list of 3. We can think of this as, again, the outer list, okay? L2 is like a train of 3 things. And then inside the first train, I've got train L1, which itself is a train of 3 things. All right. Is this okay, the structure of what's going on here? All right, so let's say we want to look at this stuff, okay? So if I subset L2 single square bracket 1, what is this? This is, it's still the structure of L2, okay? So again, we've got, you have it, I don't know if I can draw a, let me just draw like a little picture here. Something else, okay. All right, so if I talk about L2, okay, it's basically, we've got a train. So this is a list of 3. And here I've got 10, 20, 30, D, E, F, G. Okay, so I've got 10, 20, 30, D, E, F, G, H, I think. And then here, I've got the contents of this, which is 1 through 8, A, B, C, D, and 5, 4, 3, 2, 1. Okay, so a train within a train. Yeah, exactly. That's what we have here. And okay, and so when we do L2 1, basically L2 single square bracket 1 is going to be this thing. Okay, so it is still that's what this is. Okay, it's this entire thing. And so to reference this thing, we've got this double square bracket 1, double square bracket 1. Okay, and then it says, okay, well, and the contents of that is 1 through 8. Excuse me. Okay, and so we have all of this. Now, if we wanted, so that this is a list of 1, and within it is a list of 3. Okay, that's what we have here. A list of 1, and inside the list of 1 is a list of 3. Okay. However, on the other hand, if I do L2 double square bracket 1, L2 double square bracket 1, that's going to be just the inside. Okay. Oops, that didn't work. Oh, you know what? I'm on the wrong layer. Okay, I don't know what I'm doing here. Something. Okay, well, this is going to be, it's going to be this thing. Okay, the 1 through 8 and the ABC. Sorry for my terrible handwriting. 5, 4, 3, 2, 1. Okay, so the double square bracket 1 is going to be this. It's going to be the list, the contents in there. Okay, so it's not the box containing the train. It's the train itself, the train inside there. That's the double square bracket 1. Maybe I'm belaboring this too much, but it's important that we can tell the difference between this and this. Okay, the difference between the single square bracket and the double square bracket is very important. Okay, and therefore, when we do all of these things, okay, which ones will result in what? Okay, so double square bracket 1, okay, what is this? So double square bracket 1 returns this thing, okay. Double square bracket 1, 2, it says asking kind of the second element here, and it's not going to work. But if we do double square bracket, double square bracket 1, double square bracket 1, okay. Double square bracket 1, double square bracket 1. That's going to be 1 through 8. Okay, that's what we get here, and then we can ask what is the second element here. I hope that's all right. Okay. You can do double square brackets on atomic vectors itself. Okay, and it's very similar, right? A few exceptions. If you have a named vector, okay, it's going to drop the names, double square bracket 1. This is just kind of like an oddity, I guess. Okay. If you have a vector of length, say 3, and you ask for the fifth element in a vector of length 3, it's going to give you back just a missing value. Okay. All right. So we got a question. It says, is there a difference with L2 double bracket 1 and L2 1 is the first element is and the wait, and is there a difference with this? Yes. So L2 single square bracket 1 is kind of, so L2 itself is a list of 3. And so when you do single square bracket 1, it's going to give you back a list element with a where the contents is a list. Okay, L2 square bracket 1 gives you the contents of the first list element, which is a list. Okay, this is a list length 1, and this is the list length 3. Okay, the L2 double square bracket 1 is the contents of this first thing, which is a list of length 3. L2 single square bracket 1 is a list of length 1 where the contents is a list of length 3. Okay. So if you give it a subscript that's out of bounds on an atomic vector, you get back missing. If you give it a subscript that's out of bounds with double square brackets, you will get back an error. Okay. And so it depends on what you're doing. Okay. Sometimes you're like, oh, okay, well, I want to avoid errors. Okay. So you're like, okay, well, I'll just keep using single square brackets. That's fine, except later on, when you have an NA and you throw it into an if statement, then you're going to get an error, right? And so depending, these are like, it's very good to familiarize yourself with what triggers what errors, okay? Because that's how, because right now, I don't know where you are in your R programming comfort, but a lot of times you encounter errors and you're just like, I don't know what to do, okay? But you will get better and you will be able to better understand the errors. And you're going to say, oh, I recognize this error. This error means I've done this. And then you're going to be able to figure out like, okay, let me retrace my steps and figure out where something like this could have happened, right? So when you say subscript out of bounds, you know, if you see subscript out of bounds, it probably happened during some kind of subsetting operation, right? And so here, you get something like this, okay? Let's see. Does the same issue occur if we are subsetting in lists? For example, it'd make a NA element if you did L44, but an error. No, you get different things. And let's just try it out here. Okay, so let me just create this. All right, so there's L1, and L2 is here. All right, so L1 single square bracket 4 will give you a list with where the contents is null, okay? And then L1 double square bracket 4, yeah, will give you a subscript out of bounds, okay? So you'll get basically not an NA, but you get a list where the contents is null. If you give the subscript like that. Okay, let's see. If you try to subset with a 0 length element, like subset with a null or a subset with a 0 length anything, you're going to get back a 0 length thing. But if you try to do a double square bracket with a 0 length thing, it's going to error out. Okay. Oh, okay. I think this is going to answer the question that we just kind of did here. So L1 is a list of length 3. Out of bounds will give you basically a list or train car with nothing, with null inside. Double square bracket gives you subscript out of bounds, and this is a common error in loops, I would say. If you didn't define when you should end your loop correctly, you will probably run into something like this, subscript out of bounds. This is something to familiarize yourself with, okay? Subsetting a list with null or a zero length something will give you back basically empty list, okay? And trying to subset a list with null or a 0 length something will give you back an error. We'll take back an error. Okay, let me give you a second quiz answer for today. Second quiz answer is D as in dog. Oh man, I'm gonna run out of time here. Okay, D as in dog is the second quiz answer. All right, subsetting with matrices and arrays. All right, we're gonna have to go quickly here. Okay, okay. So a matrix is an atomic vector but there's a two-dimensional thing, right? And so you can make a subset of matrix in a few ways, right? One is multiple vectors. These are kind of the core, you know, which rows and which columns you want to keep and things like that. You can subset it with a single vector, or you could actually subset it with a matrix of like coordinates here. Okay, so here I'm making a 3x3 matrix, okay, with the elements 1 through 9, and I'm going to give it the column names ABC. Column names ABC, no row names. Rows are 1, 2, and 3. Okay, so you can just say I want the first 2 rows, so you can kind of subsetting it with commas in here. You say I want the first 2 rows, all the columns, and you get the first 2 rows, all the columns. You can use logical subsetting. Okay, so you can say I want true for the first row, second, and true for the first, false for the second, true for the third. Okay, so it's going to give you the first and third rows, and I want columns B and A. All right, and it does that. You can give it a 0, which will return a 0 length. So basically return 0 of the rows and everything but the second column. And so what you get is a matrix of dimension 0 rows, 2 columns. Okay, so this looks funny, but you basically have a matrix 0 rows, 2 columns here. When you subset a matrix, by default, it's going to simplify it. Okay, so so you can ask, is A a vector? All right, and it's not, because it's got dimensions. It's a 2-dimensional thing. It's a matrix, right? But if you subset to just the first row, R is going to say, hey, you know what? You subset the matrix, and so rather than giving you back a matrix with 1 row and 3 columns, it just gives you an atomic vector of length 3, right? And this is no longer a matrix. This is a vector, atomic vector of length 3. And if you say, is it a vector? It's a vector. It's a vector. Okay. This is not a 1x3 matrix. It's an atomic vector of length 3. Okay. Sorry for the overlap here, but the matrix can be treated as an atomic vector. So here I have a 5x5 matrix of the letters A through Y, okay? And I could just say, hey, you know what? I want the 8th and 9th values, okay? The 8th and 9th values. And so R, internally, it's stored as an atomic vector with just some dimension attributes. And so if you kind of just line these up, 5, 6, 7, 8, the 8th letter is H, the 9th letter is I. And so the 8th and 9th values in this matrix are the characters H and I, okay? And so you could say, I want the 8th, 9th, and 25th, and you would get HIY and something like that, okay? So and again, the way R numbers these is down the columns, okay? So it numbers them down the columns, which if you need it to number across the rows or something, what you could then do is you would transpose the matrix first. And if you transpose the matrix first, then basically what used to be in rows will now be in columns, and R will still continue numbering according to columns, but it's going to work. All right, and this would be a little bit strange, okay? But you can think of a matrix as, you know, it's this thing, and you can provide it with coordinates, okay? So you can say, I want the element in the first row, 5th column, okay? And I want the element in the 3rd row, 1st column, okay? So here I'm providing it a matrix of columns, or of coordinates, okay? Each row is a set of coordinates. 1st row, 5th column, 3rd row, 1st column, 2nd row, 3rd column, 1st row, 1st column, okay? And it's gonna select those elements as well, okay? So you can provide, so you can subset a matrix kind of with coordinates here, okay? So you're subsetting a matrix with a matrix. So we've got the vals matrix, and inside there I'm providing it a matrix of basically coordinates. So if you had a 3-dimensional array, your matrix of coordinates would need to have 3 columns. You would need to have you know, an X, a Y, and a Z type of thing. If we did not specify by row equals true, would the points be reversed? So here I'm just kind of, the points would be 1, 3, 2, 1, 5, 1, 3, 1, or something like that. or wait, no. Now, if I did not specify by row equals true, it would be, the point would go, it would go 1, 5, 1, 3, I don't know. It would just fill out the matrix column wise, and you just get a whole different set of things here. Okay, same kind of thing here. I've got this 3-dimensional array, and you can give it coordinates, and you can say I want the elements in the first row, second column, first layer, second row, third column, second layer, and that's what you get. Okay, so you're subsetting a 3-dimensional array with a matrix of 3 columns, and these are kind of the coordinates that we're pulling out. Okay, that's less important here. Okay, we're going to just see how far I can go in this subsetting the data frames. If we run out of time, I'm going to just make you read the rest of your slides on your own here. I suppose I could record like a supplemental, like extra 15 minutes of lecture if you want the video commentary. But if not, I think the slides are also self-explanatory here. Okay, so data frames are basically 2-dimensional structures, but they are stored internally like lists, okay? Which allows us to subset data frames as if we are subsetting lists. And it also allows us to subset them kind of like we're subsetting matrices because they are 2-dimensional. They've got that 2-dimensional structure. All right, so here I've got this simple data frame called DF, 4 rows, 3 columns, and it's got, the columns are named X, Y, and Z, all right? So what did I do here? Here I've created a logical vector, okay? A logical vector taking $y, I'm taking the column Y, and I'm saying, give me where the column Y is divisible by 2, right? Column Y mod 2 equals 0. So this is a logical statement. I want the rows where column Y is divisible by 2. And so this becomes a logical this is a logical statement. So it's going to be basically true for the rows where Y is even. So it's going to be true for row 1 and true for row 3. And it's going to return back row 1 and row 3. Notice I have a comma here to indicate I want to select these rows and all of the columns. Here, I don't have a comma, okay? I'm just giving it a vector of column names, and it's going to select column X and column Z here, okay? You can select the columns like you would a list. This results in the same, but there is a distinction. Okay, here I've got the comma, and this basically says I want all the rows and the columns named X and Z. Okay, so this is kind of like give me the elements of DF, where we're treating DF like a list, elements named X and Z. Here it's saying give me all the rows, but the columns are named X and Z. You can do this, rows 1 and rows 3. I've got the comma here, and I'm saying all of this, okay? However, if I don't put in that comma, okay, so notice the difference here. Okay, I say I want 1 and 3, elements 1 and 3. With the comma, this specifies I want rows 1 and 3. Without the comma, it treats it like a list, and it's saying I want list elements 1 and 3, which will correspond to column 1 and column 3. Okay, and so the comma is missing here, and we're going to get the first and third columns here. Okay, I'm just about running out of time. So I will give you the final quiz answer. Final quiz answer is E as in elephant. E as in elephant is the final quiz answer for today's lecture. All right, and so just make sure you you answer those questions before the next lecture. Final quiz answer is E. Okay, I'm going to just do a couple more slides, and then we'll call it quits. I suppose I can record just like a little supplemental video for the last few slides that we're going to miss here. Okay, we've got, if you look at the structure of the data frame, okay, you can say, well, you know what, I just want to subset the data frame here. If I do a single square bracket X, okay, this returns, okay, this will return a data frame with just that column X. Okay, so the structure of this is still a data frame. Whereas if I put in the comma and I use the X, all right, this will simplify the data frame into a vector. It's going to give me back basically the column vector with element X here. Okay. So here I'm subsetting the data frame like a list. Here I'm subsetting the data frame like a matrix because I've got this comma here. And so when I subset it like a matrix, a two-dimensional structure, it will simplify down to the atomic vector. Whereas here, it's going to preserve the list structure of it, and it's going to remain a data frame here. Okay, and then just, this is it. $X and double square bracket also simplifies it, and these both become a vector, okay? Because the double square bracket, the $sign is much like using the double square bracket, and the double square bracket pulls out the elements, and that will simplify it, okay? All right, so we'll pause here for now, and I'll let you guys look at the remaining slides on your own. I think after I'll deliver the lecture again at 6 o'clock, and then probably afterwards I'll just record a few extra minutes for the last few slides that we ran out, and you can watch that if you want, or you can just kind of read the slides over on your own. Okay, so that's what we've got. Let's see. It says, will we go over the differences between structure, mode, type of, class? I feel like I already went through mode and type of a little bit already, and class we'll talk a little bit more when we do S3 object-oriented stuff. So we'll talk about that later. Okay, but that's it. Have a good weekend. I do have office hours tomorrow at 10 a.m. if you have questions at that time. Otherwise, we'll see you guys on Monday. So have a good weekend, and we'll see you then.